right, Tony, we're live. Are you there?
I'm right here. How you doing?
It's good, man.
Hey,
Ooh, it's all working.
hey, it
Unbelievable,
is.
man. How did that happen? Holy cow.
Uh, yeah, I'm watching the stream and I see myself about a few seconds delayed. So we're there. We made it
That's
work.
all
You made it
right.
work.
All right.
You did it.
That's it. Let me see here. Oh,
Sorry, that
Brandon's
was my
in there.
bad. I accidentally it just turned
There
on.
it
That's
is.
why.
Okay. We're
My bad.
you in there, Brandon? You got your mic on there?
Yeah, I'm there.
Oh, you know what?
I
Brand-
accidentally turned on my
Did
camera
you switch
on
your
this
other
one.
mic, Brandon?
Yeah, I'm good.
I don't see you coming up. Oh yeah, you're there. Okay, cool. All right. Well, welcome, Tony. We can't thank you enough for being here, man. This is a great occasion, and we're grateful,
pleasure,
man.
man.
We're grateful.
Hey.
So
Yeah, I've been checking out your stream here and there, and
yeah.
looks like you're doing some cool stuff. So yeah, I'm happy to be here. It'd be cool to see
yeah,
what you're doing.
it's been quite the run for my son and I over the last year. I guess really is where this whole thing started. So. Which has been kind of crazy, and really where it started was we started. Well, I've been into astronomy for a lot of years, but we started building
Right.
computers here in the garage, and got pretty heavily into that. And then we decided to take it to the next level, and through this, I was thinking, I'd love to do something astronomy wise that is science related, that we could actually do something that'll actually not just take pretty pictures. I mean, that's an art in itself, and I just didn't have the patience for that. So I thought, oh man, this might be really cool to do something like this. So yeah, but it's taken about a year to to kind of figure out how to do what we're doing, that's the whole thing. So,
Well, yeah, I mean, and we live in a time where that's possible, isn't it? I mean,
Yeah.
now the equipment is here; it's available to you to do some really interesting, observations, occultations, all kinds of citizen science initiatives that are out there. You can participate in directly now, and so what you're doing with looking for asteroids, is part of that, right? I mean, you're
Yeah.
able to. In fact, I'm trying to think. I don't know of anybody else doing this. I mean,
well, and that's
maybe there are
been
people.
the challenge ultimately, because when you go to learn this stuff, what do? We go to YouTube, right? It's like, oh, I'm going to go to YouTube. I'm going to figure this out. And of
I wanna
course,
find that.
well, I go to YouTube and it's like, man, there's very little out there to try to figure things out, and but there was a couple of videos that have helped through that process, and through trial and error, and I've been fortunate enough to have a couple guys that I for me, I'm the kind of person that if I want to figure something out, I'll reach out to the guys that are doing it. So we reached out to David Rankin has kind of a video on there, and I reached out to him, and he checked some of my observations, gave me some tips on some things, and then the Minor Planet Center came back with was telling us, hey, these observations are good, they're not, and then of course we met 8Key, which really changed our world, because Mike, he's
doing some cool
it's
stuff.
great, cool stuff, and for him to see our videos and reach out, then we met, through him we meet Sam on the team and some other guys, and able to send some observations and have Sam say, oh, these are working, these are not. It's like, okay, and try to figure out what the heck is going on, man. Hey Fooney, thanks for the follow, brother. But yeah, it's just it's been trial and error. But we were fortunate. We had a guy named Peter at the Minor Planet Center that's been responsive to us, and we're grateful to him. So he's helped us out through some of this, and we've been able to have some of our observations, like put in the Minor Planet Center database. So it's kind of neat to see our small little our little observatory. Well, that's kind of a new thing too. The observatory. That's.
Yeah.
This is what happens, Tony, when we start out with an 8-inch, and now we got a 14.
Oh,
we got a 14.
yeah, you got the aperture fever there, didn't you?
So this was a crazy deal, because I'm really close to my friends down there at Woodland Hills Cameron Telescopes, telescopes.net, and I don't know if you know Daniel Mounsey, but Daniel and I have known each other for 15 years, and they were kind enough to let me use an 8-inch when I started this process, and then it was like, hey, how about an 11? Like, let's go 11, and then now it's turned into this, and it just became, hey, we got to build an observatory. So we actually built this over the holiday. This little roll-off roof observatory that's right outside of our garage. And my son and
Is
I
that a
put
port
it
light?
together.
Is that a port light in the back wall there?
It's a picture of a port thing with UFOs.
Okay.
So-
All right.
So we have like UFO stuff in there, little alien stickers and stuff in the.
Okay. All right. Well, that's clever. Yeah. Well, thinking about going to your C14, and it looks like looking at your channel page, you've also got a C11.
Yeah.
As your backup.
Of course. Of course.
So, because you do, I mean, that's what you do when you
Right.
got a 14-inch telescope. You have an 11 inches backup. When you're talking about imaging and all the stuff that people are now doing, making pretty pictures and all the stuff that so many people are doing a great job with right now, with what you're doing, I mean, I'm about to ask you what the magnitude is of some of these things you're looking at, but you've got to have that. You've got to have the aperture to see these things. And what is the magnitude of a typical minor planet or a typical asteroid?
Well,
that you're
so
looking at?
like right now, we're actually imaging as we're talking right now. I've got let me reset this back here. I'm actually got some imaging going on as we're doing it.
Yeah.
But the one we're looking at right now is pretty it's pretty bright. It's a 14 and a half magnitude, but I'm located about 35 miles north of Los Angeles. So I'm actually in Bortle 5 skies, which isn't the best by any stretch.
No.
But I can capture. We were doing some stuff on this on stream 3 or 4 days ago, and I was getting just under 18 magnitude with this. If I stack a few 30-second images together, I'm catching almost 18 magnitude. As long as I've got a decent no moon out, the sky is decent there. So, so which is I mean, look. A lot of the sky surveys now, these guys are out there looking at 22 magnitude, 21 magnitude, 20, those kind of things. I mean, as you know, part of the team, we're also trying to, work with Henry, who's part of the Atlas program, and do follow-up study for those guys and stuff. So, but we're limited probably to about 18 magnitude with this setup. Now, I'm rocking a Hyperstar on the front of this thing. So, so that and if it wasn't for a Hyperstar, I wouldn't be able to do this, because this is shooting f2, and I'm able to shoot these things at 15-second exposures and just capture a whole gobload of light right now. So right now unfortunately I took some images earlier. We're starting to get into the my setup. There's kind of a tree back here. In this part of the sky, this asteroid happens to be kind of low in the horizon that we're looking at right now. But
Okay.
But I'll pull it up in the Astrometrica and let you see. So we're getting some blowout here that we normally wouldn't have. But
Okay.
But yeah,
Because
basically
it's low in the sky.
yeah. But basically, I mean, I'm this right here, like this is an image I just uploaded to astrometry.net. So I'll start. That's literally a 5-second image with the Hyperstar, with all that data in there. So
What's the field of view there?
well, we're rocking. What are we rocking on that?
Wait, on the 14 one?
Shoot, man, we're 600 millimeter with this thing,
Uh-huh.
and let me
The
just
focal length?
Yeah, the focal length 600 millimeter, and the let me just recall. I always forget what the. I can tell you here in a second because I have it written down because I always forget. Field of view is about 2.4 degrees.
Wow!
is what that
Wow!
is.
Wow! That's not. That's really big. Okay.
Yeah, it's a really big image that we're looking at. So, but basically, what I do is we'll take these images in SharpCap, and then and I'll kind of take about a 15, 20 minute spread on these things. 15 minutes worth of data. I'm going to stop these because we're kind of getting in this realm. But I'll take about 15 minutes worth of data, and then what I usually do is I love astrometry.net. I will upload the very first image, so I can just I'm going to plate solve in Astrometrica, so I want to know exactly what that RA and DEC is of that very first image. So what I'll do is here's a 20-minute run of 5-second images right here that I just took before I connected with you tonight. So I'll grab that first image. Have you used Nova, astrometry.net at all?
No.
This is slick, man. This is like find your phone for
asteroids.
Any kind of plate solve. So any images you have, you can upload to this website, and it'll do a plate solve for you automatically, which is really slick.
Yeah.
So it helps me, and then I have some fancy, log sheets that I just kind of keep track of RA and DEX of things as I'm going out. And this is all just stuff that I've discovered through my time. So it's going to do a result here, and it usually takes a minute or two, and it'll process up, and then it'll give me it's going to go through and do all these triangulations to figure out where it's located in the sky, and what's happening there. So usually I'll sit here and spam the refresh on this thing, like, come on, baby.
Yeah.
But this tool works really well, especially
you can see the sky glow on that one too.
Yeah, well, you can, and unfortunately I have a what you're seeing right here is actually a street light. This part of the sky that we're looking at right now, at this angle, normally we're kind of pointed. We have the southern east. We have a big wide open view, but this kind of lower in the sky, I've got a light, street light that's bothering me a little bit right there at this angle. But I can still see it started the cue now. It's showing the screen here. So let me there. So boom, it just gave me all of my data on that file, on that image.
Where is it?
Right all here.
Oh, okay. So the center of the image, RA index, is that what you're looking at?
Yes. So that's, and what I'll do is I'll write that information down.
So you're looking at 1.5 by 1, almost 1.2 degrees. Pixel scale is 2.29. Wow. So it does a lot. It
does all that calculation for you. This is really a slick program if you haven't messed with this before.
And then can you add this information to your FITS header, or does it do it already?
So it doesn't do it already. All that's in the FITS header from SharpCap is basically the timestamp is what's in there.
Yeah.
So now that I have this data, what I'll do is I'll go to Astrometrica, which that was really probably the biggest learning curve of everything I was dealing with, is just trying to understand that software in its sense here.
Sounds like PixInsight for a lot of others.
Yeah, for sure. I'm loading it right now. It takes a second here. Okay, so we're gonna replace this. So then, what I do is I'll start adding these images in here, and no problem.
Do not disturb. Thank you.
So here's all my images. So what I'll do is, normally what I do is I do a couple image stack of something. Sometimes 3. At 5 seconds I could do 3, 2, 3. But basically what I'll do is I'll start stacking these images up, and I'm going to add these. And then, see, there's the timestamp. So I have a sync clock that this thing is running to, this Dimension 4 software that my whole system is synced to. Right now I'm synced to the UCLA time clock, but it's basically the universal time, so everything is time synced, which is the most important thing when you're trying to do observations of these things. So then I click through those, and it says, okay, we're going to track and stack these things. Well, this software will actually calculate the motion of the actual asteroid itself. So I'll do a search here from database. We're looking at 1999 GJ4, and I'll double click.
Yeah, I knew
that's
that.
not the right.
That's the one I was going to ask.
Is that the one you're going to ask for? So let me. I grabbed the wrong one there, so let me try that again. But GJ4. So there's that. Now I get to put in that wonderful information that I got from astrometry.net.
In the header.
In the header.
Good.
2231, and we're in the south.
Oh, you manually do. Okay.
So you manually put it in, and it should, with good flats and stuff that you've taken, this thing should just automatically pay full. It's going to go out to the database and check. I'm using the Gaia catalog is what the Minor Planet Center recommends, and and it's
Yeah,
gonna
it's a
go out and
good
do its
catalog.
thing. Good catalog. So sometimes it takes a minute and hangs, and you go, oh no, it's crashed. No, Astrometrica is just kind of like that. Boom. So there it plate solved. So it automatically plate solved. It gives me my residual errors on my image, which anything below like 0.25 is very good. So we're getting 0.19, and so our plate solve is very good right now. So what I'll do is, so we got 3 images stacked there. I'm gonna go down, and we'll go a few minutes apart here. So let me go down to we'll go down to these 3, which are about 29. Yeah, you know, these are about 4 or 5 minutes apart, so I'll stack these up and put these in. And I'll just keep the same RA and deck, and let's see. Sometimes you actually have to do a manual plate solve where it'll say, hey, it can't see it, and you have to kind of point it around. But like I said, if you got good flats, this thing will generally do a really good job of what it needs to do. So I'll grab some, you know, few minutes down the road here.
So wait a minute, what's all those green circles? Are those the stars?
That's the stars that it recognized and plate solved.
Oh, so, wow! So a lot.
It's capturing all those stars on your plate.
So when it says it's extracting objects, it's talking about stars, not asteroids.
Stars.
Okay.
So what I've done now, so now I have three image stacks here, and what I'll do is I'll blink these guys together. So here's these 3. Now Astrometrica has a wonderful database that I've uploaded into it, and it knows what the objects, because it's plate solved, it knows all the objects that are in this field of view, the known asteroids that are cataloged in the Minor Planet Center. So right now,
find it.
Yeah, here's the all the asteroids that are known. Now some of them are up to 21.3 magnitude. You can see there's an 18.6, there's a 20.4. Our asteroid is down here. And
now hang on, you're not seeing a 21 magnitude.
No, I'm not seeing it. I'm not seeing it, but the database is telling me it's there, but I can't see it obviously with my.
So we need more. We need to co-add more images.
That's right.
Yeah.
But you look, there's our asteroid flying through the field right here. There it is.
There we go.
I'll invert the image, and there she is.
Yeah. Look at that.
So that is three stacks about 5 minutes apart. Now you get to learn. Hello, General. How are you, sir? Welcome to the stream, man. We got Tony Darnell with us tonight. It's fantastic.
Hey guys. I just have to ask: is it funny or Foony? I think it's Foony.
Foony, yeah, Foony's there.
It's Foony. Okay, that's what I thought Greg said.
Yeah. So, here's what's neat. You get to, you kind of see how this asteroid is like. Wow, this thing looks like it's really kind of moving. I'm going to show you another really, before I take some measurements on this thing, I'm going to show you another neat.
So it's magnitude 15.
Yeah,
16.
Another neat website that you should check out. And if you haven't, have you seen this this CS orbit view?
Not this particular one. No.
Okay.
This one.
So this is from David Rankin, the guy that, of course, did a asteroid video that has a great YouTube video on how to actually do some of this stuff. He wrote this software, and it looks like I didn't even know this. Looks like the Catalina Sky Survey actually put it on their website. I'll drop a link to it in the chat for you guys. But so what's neat about this is this thing's linked to the database of the Minor Planet Center. So any object you put in here, it's going to tell you what the orbit is. So right now we're looking at 1999. What is it? GJ4, and you hit this little Find McOrb button, and there's the actual asteroid's orbit. And you can move around this thing and kind of see where it's at. You can also, what's really neat, there's this neat slick little slider right here that you can.
I wish I'd known about this when I made that video on Apophis.
Yeah, I know, you saw your video on that. So look, so this thing, like, look, you can back up in time and go fast or slow and just kind of see where this thing lands. It also will tell you the distances as you go along from. Get zoomed in here. the distances of how close it gets from the Earth to the Sun. I don't know why it's not showing that right now, but it normally does. Right here, normally down here, it'll show you how close it gets to the Earth, but you could sit here and futz with this thing and take a look at how close you get and how far you get and all these kinds of things, and it'll give you some of that data, which is really, it's really slick.
Nice
but
graphics.
But you see, like here's our flat orbital plane, right? Well, look at the angle of this thing.
Yeah.
Right.
Yeah. No, it's coming. It's pretty high.
So now you know why it looks like it's flying.
Yeah.
Flying through the image pretty fast at 5 minutes apart.
So
images.
go back to that. Go back to the orbit again.
Yeah.
What's the date? I didn't see the date on. Is that tonight that you were just showing?
Yeah. Well, right now, if you go now, this will be basically it says 2:20 at 2:0250. So this was. Well, this was at 0250, so this was what, an hour, just over an hour ago.
Yeah, yeah.
You know.
Cool.
But yeah, this is really a really slick piece of software. Website to use especially. So yeah, I saw that thing you did on Apophis, man. That was very cool.
Well, yeah, I want to, because 2029 is going to be a big year for you guys.
Yeah.
I think you guys will be able to do a lot of cool stuff, even way before that too. I'm sure, before it even gets here.
You know, it's funny. I had somebody today, man, on Facebook, like asking me about. You know how the news is. You know, it's like anytime there's an asteroid close by, it's like, oh boy, you know. So they were freaked out because the news clips were coming out, and they're just like, oh my gosh, you know, and we try not to ever talk about doom and gloom on our stuff ever. We're here for the science. We're not here for, let you know about that. But I told the guy at the end of the day, I said, listen, man, people have a much better chance of getting into a car accident than an asteroid running into the Earth currently. So don't worry about that.
Well, that's true. You're right. And I mean, I am not a doomsday person either. I mean, things like the solar cycle getting out of whack, or having Nibiru come at us, all of that stuff is all of that's nonsense. But the one thing I'm very glad about is that people like you and the NEO Center at NASA and NEOWISE and all these other space telescopes looking for near-Earth objects are looking for near-Earth objects, because it's what we don't know
right.
that could get us, right? And while you're right that the chances are small, they're not zero, and
of course,
it's definitely worth taking a look at. I mean, it's only close to zero when you don't know that there's one coming right at you. So this is valuable work. It's something I'm glad that you guys are doing every night or every clear night, and as well as NASA and Gaia and TESS is even doing it, right? Because
absolutely,
when it's looking at certain sectors, it can see transients as well. So, I mean, I think of all the things that could get us, not Betelgeuse dimming and even Betelgeuse exploding, nearby supernova, maybe a gamma ray burst would give me pause if it were close enough.
Right. Of course.
This is the thing, right? This is the danger.
That's true. You're absolutely right. You're absolutely right.
And so it needs to be done. It needs to be looked at. We need to know everything that's out there. What is the ratio? So we always hear that there are 5,000 or I don't know how many thousands of NEOs that are cataloged out there and known to NASA. But they also say that that's some percentage of what's out there.
Oh, I'm going to say it's probably 20% of what's out there.
Okay, well, let me ask you then. Good, because how do they know that? If we don't know how many, if we haven't seen them, how do we know they're out there? Is it because the masses?
Well, the masses of the amount of rocks that are in the asteroid belt is out there. It's that judging from the amount that they find on even a nightly basis, I guess you can kind of start to round and figure, like, holy cow, like, if you start to discover X amount per time, I mean. The ones that are the challenge, especially, are the ones that that freaking have the sun at their back right now. I mean, what was it? Just a few months ago, I had people like texting me like, "Hey, why didn't you see this one asteroid that just popped up the other day?" And it was literally, well, we had one. I showed this the other day. We had one that came within the orbit of between us and the moon. Did you see that?
Did you see
it?
Well, I
Okay.
didn't see it, but I heard
But
about it.
you heard about that, right? So,
I heard about
and that was just discovered in January.
Yeah.
You know,
See,
so,
and that's exactly my point.
Right.
So, and of course, you got things like say it for me, Chebalians.
yeah.
The Chebalians.
I know what you're saying. Right.
It was a bolide that hit, exploded in the atmosphere
Over Russia, right? Yeah.
Yeah.
Chebinsk, so, yeah. Right.
I'll screw it.
I know.
Anyway, but again, came out of nowhere, right? And that could have been. Now, according to what I know about the Apophis style, those close encounters, those happen about once every 1,000 years. So we're.
Oh shoot! I just lost him.
What happened?
I lost you, Tony.
I can hear him still.
Do you?
Yeah.
Talk, Tony. I lost you. I lost his audio. Shoot. Why did I lose his audio?
I can also hear him on stream, so
Can
your
you?
headphones probably just...
Why did I lose you?
I can hear him. It's so weird.
I don't see him on the desktop
Can't
audio
hear Tony,
anymore.
huh?
I don't see you on desktop audio anymore, Tony. Bummer.
Hold on, I'm muting for a sec.
Talk, Tony? Yeah, I don't have him. Shoot. Let me try to recall you back and see what happens here. Does that work? Okay. I saw your voice. Your mouth said sure, so I'll try that. Hang on. Okay. Gotta love technology. Sorry, guys. Stand by with us here. What happened? Brandon, I lost you too.
Oh, really?
I don't hear you anymore.
No, you haven't been able to hear me at all. I've been muted this whole time.
Okay. Are you in here though? Are you in the
Yeah,
call?
yeah.
Can you unmute yourself here?
No, because I'm using your thing, remember? But I can hear myself on the stream.
Come here a second. Oh, it sounds like Discord's having issues with calls today.
Oh, he left. Oh, wait. Okay, now, do you hear him?
I just joined. I
There
just
you go.
rejoined the call.
I got you.
just rejoined.
Yeah, I got you.
Oh, okay,
okay,
cool.
Okay. I don't know what happened.
I just left the call and rejoined
I
it.
think
Oh, you did?
Discord's
Okay.
being whack.
Well, we got you back, so
Yeah.
that's good.
Yeah.
Can
cool.
everyone in
All
chat
right.
hear him?
Let me try one quick thing. I want to make sure this.
Well,
is-
Third Rock. Hey, Third Rock. He said that they were having issues at Discord today.
Yeah.
Okay. Good to know.
Yeah. So okay.
I want to while I'm talking to you.
General Derpado. Sorry, I just.
Oh, that's what's doing it. Okay. That is what's causing the issue here. Hang on a second. I think I know why we're losing audio. I just
Hold
lost
on.
you again, but I think
Give
I
me
know
one
why.
second. Did you figure it out, Dad, or no?
I think it's because I switched from one computer to the other, Brandon.
Really?
Yeah, I don't know why I'm losing it. Tony, one more time. Leave the call and then come back. I won't do that again, so. You there?
Hello?
There you go. Okay.
Okay.
Interesting.
So I have, well, let me show you this. This is our crazy setup we have here.
I'm
So-
sorry, what? Oh, go ahead.
You see that? You see that on stream there, Tony?
I know. I saw that in your last stream. I'm like, look at that.
So,
SpaceX and it would be jelly of that. I mean, look at those monitors, man.
so we have a couple computers running, and I have a KVM switch that allows me to. So the three screens we have right now are running the stream, the camera, and then you. And that's this red computer that my son and I built on the side here. You see the red box that's there. And then I have the computer that's behind me that you see normally on stream is running this 49-inch ultra-wide. So, but I have a KVM switch that for my one keyboard that goes back and forth. And when I switch over, That's why I'm losing you. So I won't do that again.
Oh, you know what I use for that? I have I have 3 laptops, all different operating systems, Linux, Windows, and Mac. I use a program called Synergy for that.
Everyone
right?
uses that.
You're about the 4th person to tell me this, and I need.
I love it, man. It just works, and I love it.
We're gonna make a change. We'll do something on that. So, yeah, for sure.
Like, I've got Linux back in my life. That was something that had to happen. Well, I was so sick of Windows. I thought I was gonna. Right. Every time I'd start a stream or a Hangout or whatever, Windows decides it wants to update, and then it took like one time it took a week, and I couldn't even use my laptop.
Oh, really?
Update. It was so busy. Oh, I was so mad. So anyway, all of that is to say, Linux is my friend.
For sure, for sure. Well, I understand. So I'll go back to this. I'll just show you basically what we do once we've got a few measurements here that we can take. So what I'll do is I'm going to go to the first frame of this thing, and I'll zoom right in. And this is the power of Astrometrica, which is totally awesome. So the beautiful part is we're in the Astrometrica, based on the database, says, man, we hope this thing is in the red box, and we can see that it is. Sometimes it's not. That depends on the amount of observations they have and what they have going on, but a lot of times it is. And so what we do is we'll just kind of hover over, and we will click the dot, and then we see a light curve on this thing. So there's the asteroid right there, and it's going to show us a light curve and all kinds of signal to noise ratio on our image and all this kind of stuff. And these are the kind of things that get put into this this ADES file that we create for the Minor Planet Center. So
and they just add it to their
so they'll
list
go,
of
and what they'll do is they'll take a look at our measurements, see if they're if they're good, and then if they're good, they'll get put into the orbital solution of this thing. So what I do is I say, okay, I can see my crosshairs kind of on this. I got kind of a light curve on this thing. I'm going to go to object destination. And it's going to go to the database and say, hey, we think this is 1999 GJ4, which we know it is. So we hit OK, and then I hit accept, and boom, I've taken an observational measurement. I go to the next frame, click it, search it, OK, accept, next frame.
Hang on, who did the searching? Astrometric?
So, Astrometrica. So you hit object destination. And it comes up. It says there it is. You hit OK. And it tells, like, it's telling me the magnitude of what it thinks. 14.6 is what it's reading in that image for the magnitude, which is what the Minor Planet Center says this thing should be at. Sometimes that number's a little different than what it says, but it just kind of depends on your image. And you hit accept, and now what it's done is it's created this report file with all this information on here. Things like your plate solve that you have, your signal to noise ratio, of course the RA and DEC, your magnitude, the catalog you used, all these kinds of things are what gets sent to the Minor Planet Center on that.
So this Gaia catalog that you're using, it says Gaia 2. Is that like the second data release?
I believe so. Let me go to, in the settings, I actually have a choice. Let's see, right here in the star catalog settings, you have a choice of various catalogs. We had UCAC4, Nomad, there's all these ones in here. We were using UCAC4 for a while, but since then the Minor Planet Center's pushed everybody, starting to push everybody over to the Gaia.
Yeah, well, that's because it's really good. That's why.
Really good, and it really makes your plate solves rock.
Yeah, it says DR2, so okay.
Yeah.
Yeah, that's okay. Yeah, that's cool, man. God, I can't believe this. This is really intense.
Intense, right? So that file's created, and that's the file that we upload to the Minor Planet Center. And what I will do is, so I've done data release 2 is what Alex Helm says. Okay, so
right.
It's really funny, Tony. Like I said earlier, my son and I have just been doing this for a year, and it's like I know nothing to know nothing. I feel like I actually had a gentleman, a wonderful astronomer from Germany, emailing me the other day and questioning a few of my observations and saying, okay, you need to work on this and that and this and that, and and he's right. I mean, we're always trying to fine tune this stuff. But I told my son, I said, look at little old us. We got this great guy, this great astronomer in Germany, like emailing us to tell us how to do stuff. You know, it's pretty funny.
It's the times we live in, man, and you know, it's only going to get better. I mean, as equipment and software like this just gets better. I mean, not only that, man, but you know, okay, great, you've got a C-14, that's cool. But Gaia is a space telescope that's up there right now, taking data, measuring billions of planets and stars, measuring billions of stars to precisions never done before. And you're using that catalog now,
right?
You know, I remember back in the day. I'm really old, but you know, the Palomar Sky Survey was the big thing, right? And you had to actually go and get plates from a file cabinet and figure and use reticles and stuff to figure out what the hell you were looking for.
Right.
So, you know, we live in a time where the kind of work that you're doing we've just started, you know, and the fact that you've only been doing this a year, and are doing this kind of work is testament to the times we live in. So I'm really amazed and really happy. What is your community like? How big are Asteroid Hunter?
I don't.
How many people are doing what you're doing?
Very not a lot. I mean, a lot. It's. I mean, if you go into, like, if I go into here to the Minor Planet Center, I can look at. So we did a lot of observations on 2002 PZ39, and you could got to go down here and start looking at. There's a lot of observations from, you know, there's a lot of various observatories around the world, but when you start going through these lists, you start to see a lot of the same guys, you know, throughout here.
Yeah, you're going really fast, but it's
but I'm showing you. It's like you kind of see the Stewart Observatory, Mount Lemmon, of course, in you know, up the Catalina Sky Survey guys. Pan-STARRS is in here. Mount Lemmon, this one's pretty big. You see them quite often. There's Pan-STARRS again. Here's Atlas.
Like that is like a survey there.
Yeah, there's Atlas.
But these are
here.
professional, right? These are like professionals doing this work.
These are professionals.
Yeah.
You know, I was going to show you. I was going to scroll down here and show you, which I think is funny. So here's Mount.
What we need is like Astrofart 69 on there, you know.
Well, and here exactly right. But I was laughing because the first when we got we only got our observatory code finally a month and a half ago. They finally Peter, you know, gave up the reins, said, "Okay, man, you earned it." You know, it was like, okay, and we finally started getting our stuff in. So here's us, and here we are right next to the big boys. You know, with we're right here.
Oh,
we're
AHS, yeah.
AHS. We're U71, and we're in there next to Atlas. You know.
Yeah.
Wow. It's pretty cool, right? So,
yeah.
But yeah, I feel like the community as a whole is there's a lot of observatory codes in the Minor Planet Center. If you look at the database, there's a ton of them. But you know, it's like everything else. I think I don't think people think it's sexy science as much as of a well, what's hot right now? Exoplanets are where it's at, right? Like that's like the sexy science right now, man. Like exoplanets.
Well, you know,
that's going on, right? You know.
Yeah, and that's another area where telescopes like yours are able to do transit measurements. I mean, it's just something you can do. I worked with Tim Brown, who was one of the first people to discover. Tim Brown had, as a graduate student, Dave Charbonneau, who's now the guy in exoplanets, and he had a Meade. He had a Meade. I think it was a 14-inch, or it was the LX 200. I forget the size now, but anyway, it was setting. He took the scope off of that, used the mount from Meade, and put his own Schmidt camera on it that got about a 2-degree field of view out in the parking lot of the High Altitude Observatory, and he was looking at one of the first. I forget, it was one of those long HD blah 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 names, exoplanet transits, and this was in 98 or something like that. So now scopes like this, scopes like yours, can do transit measurements as well.
Well, and we're at, I mean, as you know, since we're all in the same team with AKI now, this is we are doing some stuff for tests, and this this is something we will be
That's right.
working on. You know,
that's right. His group, and man, he's got some nice stuff too.
Yeah, he sure does. He sure does.
That plane wave is like, yeah, baby.
I know, man. I know.
So
that's for sure.
yeah,
you know,
I need to figure out how I'm gonna get. We're gonna do some streams together, I think, coming up here. So that'll be cool. But I don't know when. I'm hoping that the Worldwide Variable Star Hunters and all those guys we're gonna do some stuff together. But I'm not sure what.
Well, and we also, as you know, we do we're doing the supernova stuff, and my son and I confirmed our first one a few months ago, and we did it right here. You're right. It's amazing what cameras and stuff will allow you to do right out of your backyard.
Yeah, you got some nice stuff here. I like this. I like this stuff. I'm looking at all your stuff looking at your channel page makes me go, man, I got to work on mine.
Well, we're fortunate.
I don't got anything on mine.
We're fortunate to have the support of our guys at telescopes.net and those guys to help us out too, for sure. You know, but yeah, it's gotten insane. I mean, but you know, I tell people, look, the real reason I started this was so I could spend time with my 15-year-old son. I mean, that's where this really started. You know.
So, Brandon, what are you doing? You're sitting over there working. You're not playing like Super Mario.
I'm not playing any games. Don't worry.
Okay, cool.
I have the stream up, and I'm just watching and talking to people in chat, and that's about it right now.
Okay.
Yeah, he works the stream.
You're looking
for me,
real busy.
Is what he does. So he works a stream and keeps an eye out and lets me know if people are. Because sometimes I get totally caught up in what I'm doing that I can't pay attention to the chat. And he'll let me know when there's questions going on and stuff, because it's like
I suck at multitasking too. I can either do the stream or I can talk with people in the chat.
Right,
but doing both.
I just can't do it.
Where I was, it's like, what was I talking about? Oh man, and it's because I'm too old for this, right? So I'm like, okay, I want to interact, because that's what you do on Twitch, is you spend time with people, and so. You know, I spend more time doing that than I do actually presenting any decent content. So,
well, and you told me the other day. Obviously you got the great YouTube presence. Have you been new to chat or to Twitch? I mean, have you just kind of started in that realm?
Yeah, Twitch actually reached out to me over a year ago and asked if I would consider putting some of my content on Twitch, and I knew about Twitch. Just like everybody else, all about gaming. So I never really paid any attention. My son does it, but I was looking at what people were doing. Back then, I was looking at Skylius and Dots Valdez, and those were the big science guys. They still are, doing science streams, and they were spending 2, 3, 4 hours a day, streaming. And I'm like, I don't think I'm that interesting. What am I going to do for 3 hours every single day? And I was like, well, I could maybe do some constellation stuff, or maybe use Stellarium. And I went through all that, and I saw people doing that, and I was like, well, they're doing a better job of that than me. So it's still taking me a long time to figure out what the hell I'm going to use Twitch for. And so right now it's all about T Cubed, which I just on Tuesdays I stream for an hour. But I'm still trying to figure out. Of course, Econ Greg has got a great community now, and with Foodie here, and you guys are building one, doing real work. And I'm thinking, wow, this is real. I just would rather participate in what's already out there than really try and do anything more. What I stream on YouTube is completely different, because the people there are completely different. And I would never do on YouTube what I do on Twitch, because I'm too self-conscious. And just face it, YouTube is it's brutal. So that's
well, and we have a YouTube channel. I don't know if you saw.
Yep.
And,
I subbed. I'm a sub.
So we and I found that, I mean, really it's the 20-minute videos that sail on YouTube, and for us it's like, it's hard to make a 20-minute video when we're doing this kind of stuff, I mean, we try to, I mean, with our support from telescopes.net, we try to do some equipment reviews for those guys and show some of that stuff. So that's primarily what it's for. But Twitch allows us to just kind of turn the cameras on and talk to people and chill and enjoy and just do the work, and just let it go. That's the neatest part of the whole platform, is just being able to do that. I think so, for sure.
Yeah. Yeah. So, I mean, the work you're doing here is just is really cool. This is really nice, and I'm impressed at the amount of things you're able to do just automatically. I mean, you're pushing a lot of buttons right now, but you know, it belies the work that's actually getting done, right? These plate scales or these plate solutions and the object detection is a pretty big deal.
Yeah.
So.
Well, yeah, and you know, it's funny. I see the library of books behind you. So if you've seen on some of my streams, we actually have an astronomical library here on the other side, and I gotta tell you, man, you want to know what really got me into this was, for the last year or two, I got really fascinated with 16th, 17th century astronomers, and just the work that they were doing with just nothing, with just minimal equipment, and taking measurements and doing stuff, and like doing some stuff. Like, whoa, man! Like, holy cow! You know, I'm fascinated by you know, William Herschel and Caroline and those people. Just the stuff they were doing just was just an incredible thing.
It was painstaking.
Amazing.
It was painstaking.
Painstaking. And then somebody like Caroline, who had zero, you know, schooling, didn't know math. I mean, William's the one that taught her, and you know, I was reading. There's a book called Fire in the Sky, and it's just recent, like 2018, and it's all about asteroids and the science behind it and kind of the stuff they're doing. Well, they did an interview. They were sitting there at the Mount Lemmon Observatory, and there's a guy named Kowalski who works for the Catalina Sky Survey, and he probably has more observations and more discoveries of asteroids than probably anybody, because he's sitting there on a nightly basis looking at all the sky surveys and discovering these things. Well, from what I read is that the guy used to be a truck driver. And now he's doing this, and I just was like, you know, he had a love for the science and for astronomy, and loved asteroids, and somehow, you know, was able to find his way in there, and now he's doing that. But he used to be a truck driver, and I told my son, I said, "There's hope for us, man. There's hope for us."
You're doing great. No question about it. No question about it.
You know, so
yeah.
But yeah, I was gonna show you. I'm literally just kind of taking some images over here. There's an asteroid, 1991 FE. But you see, look at all the. These are all the known asteroids in just this one field of view right now. You know, it's just like, holy cow. You think that there's a lot to be cataloged. You know, look at all that. This is just one little spot in the sky we're shooting. You know.
And these are, so are you blinking right now?
I'm blinking right now. Yeah, I just took a couple of images. I'm looking down at this guy down here. Let me go down to this guy right here, which is, he's barely moving, because he's moving in our orbital plane. But there's an asteroid right there that we're imaging here. So let me grab another just set so I can have couple more down the road here.
Why are you picking him of all the ones out there?
I'm because he's bright, and I just wanted to go through the process with you again. So
okay,
just showing you, just going through it here. So, but one thing I wanted to show you was some of these images, the amount of asteroids that are just in one little spot in the sky. Sometimes you can barely even see the screen. There's so many of these red description banners in here. It's like, holy cow. And we've got a few of them that are like, there's this guy. This is another one we were looking at down here that we could look at. But if you look at these guys, it's like there's just a gob of these. Now, a lot of them are all 20 magnitude. We can't see them, but the database says they're there. So we've got one here that we can see. We've got another one that we were kind of looking at right here that we can see as well. This one right here has a name to it. This one's a little bit older asteroid. You know, in the days they used to name these things after, you know, ex-wives and all kinds of other stuff, you know.
Then the IAU stepped in.
Yeah.
No.
Exactly.
Stop that.
It's right. Melissa Brucker is the name of this one. Melissa Brucker. Appreciate the follows, guys. Thank you, man. Thanks, Dad.
Yeah.
But yeah, Melissa Brucker, man. Like, okay, you know, whoever that was, somebody's ex-wife, you know.
Yeah, yeah.
Which is just a
Now
funny deal, you know.
well, they, what was it? Ultima Thule, when it was Ultima Thule, I forgot what they call it now. But the IAU, I guess they got flack for it, right? For calling
Yes.
it that.
Yeah.
The New Horizons flyby thing. And so they called it something else. I'm
So
drawing a blank on what
listen.
it is. But.
So I read this, man. Listen to this. This is hilarious. This was in that book, that Fire in the Sky book. So there's an asteroid. I can't remember the name of it. NASA landed on. We put a rover on it.
Oh, yeah.
Or not a rover. We landed on it and we took some samples.
And you talking about Osiris Rex?
I don't think it's not Osiris. I know
that's Bennu. That's
Bennu, right?
Yeah.
Is it? There's another one, I believe, and maybe it wasn't them. It was Japan.
You talking about the comet? You talking about the comet?
Maybe the comet. Somebody,
okay,
either Japan
yeah, 69P
landed.
Churyako
right?
or something. Yeah.
So, well, the point is this: is that I read that somebody purchased the rights to that asteroid, and then turned around and sent a bill to NASA for parking their spacecraft on the rock, and sued them for it.
Yeah. Good luck. Good luck paying money off
it
of
ended
that.
up getting thrown out. I read about, but it was like, holy cow! But see, none of this. A lot of this stuff isn't. This is. You can buy some of these things. You can buy rights. I mean, some of this stuff's not really regulated.
And it also doesn't. It also doesn't mean anything, right?
That's right.
I mean, you
That's
could
right.
buy. It's the same kind of thing as like you could buy a star. Remember those times
Right.
when you could
You buy
buy a
right.
star, get it named after somebody that you care about. Well, it's completely nonsense because
right.
only the IAU names anything, and so it is governed. It is regulated. So you can't just go, well, I bought you a star. Here you go. And then if anybody goes there, say, well, you can't do that. That's my star.
Do that. It's my star, man.
Yeah, that's right. That's my star.
But I laugh because this is the world we live in. It's like that somebody.
But somebody, yeah. I mean, people have approached me. People who don't know how I feel about that, morally, and they go, to raise money for Deep Astronomy, what you should do is sell certificates of like a constellation or a piece of the sky or something. No, I am not doing that. There is no way I am doing that. But it could just be a gift thing. They'll like to have it on their wall. Like, no, I'm not doing that. So yeah, I mean, because back in the 70s, people, they've been doing it for a long time. But yeah, it's so that does not surprise me that somebody would do that with a comet. What was the name of that mission? It was ESA that landed. Rosetta. Yeah, Rosetta. And the Philae lander was what they tried to land it with.
So yeah, Osiris Rex, we are part of the what is it called? The Finding Asteroids study from the University of Arizona. That is the Osiris Rex mission stuff. They have asteroid follow-up stuff on some of their.
So you guys are following Bennu yourselves?
Yes. Well, we're aware of it. I haven't really gone and done. When they call me out to do stuff, we've been doing other things. So.
So if I ask you to show me Bennu, you're gonna be like, "No, I'm busy right now.
I'm
Go
busy
away."
right now, man. No, it's just all it all depends on obviously where it's at right now. But yeah, so you go to the you go to the Minor Planet Center, which also took a whole lot of trying to figure out how to. There's so much of this website I still don't know about, but we were able to find some stuff online on how to actually create an observation planning for the night. So what I'll do is I'll go into this thing and say, okay, I can look at the NEOs that have been discovered over the last couple of days that need follow-up data from the sky surveys. These come from places like Atlas and Catalina and Pan.
So this is a list of objects they'd like followed up.
They like followed up. So, but 9 times out of 10, a lot of these are just a little bit out of my range. You can see if I look at the magnitudes, they go all the way up to, well, this one says 31. I don't know these right here. This.
Oh yeah, 20
this
to
V
29.
20. Yeah, so it's like
good luck.
Good
31.
luck with that. 31.
Get that one.
So, but sometimes we'll go into them, and the observation may be like, hey, yesterday I can tell it's coming closer to us, and it's getting brighter, and it's like I may be able to catch it, but these are the ones that are I normally look at these immediately because what we're really looking for is Atlas stuff because we want to do follow-ups for those guys. So we're trying to see if there's anything they have out there. But then what we do is we'll go to this NEO services page, and we'll go to this observational planning, and we have this kind of this thing to fill out, and we'll put in our parameters. So my RA range, we basically go from 0 to 360 degrees around, just all the way around. And then our deck range, anything below negative 25 I just can't see because I got a hillside behind me. I'll put this up to leave it at plus 90. It's fine. And then I'll set my magnitude range at like 18. And what it's going to do is just give me a list based on these parameters. Motion range, I discovered that we need to put 222. That was from a Basil Rowe video that Basil, who's very good at doing observations. This is kind of, I stole kind of his layout, Basil's layout. So this is kind of what he does. And then basically any of the objects not seen more than one day, if anything that hasn't been seen more than 1 or 2 days, generally can be lost. If it hasn't been seen in a couple days, that tends to be lost. Now, consequently, we do have a guy on our team. You've seen Sam, A Person 1, Sam on our team? You see him in the Discord.
Okay.
And on our Discord page, we actually.
Oh yeah, I did.
So I just created a actual asteroid science tab on our Discord, by the way, for asteroid hunters, and Sam is heading that up. So Sam, if you're watching, I can't remember. He's in his 20s, I believe. This kid, man, gosh, this kid is such a genius. I love this kid. So he specializes. What he does is he goes and looks at sky surveys, and he tries to discover lost objects and reacquire them based on their. So he'll look at their old orbits, and forgive me, Sam, if I get this completely wrong. I'm sure you'll correct me, but he'll look at the orbits and then he'll go, okay, based on these orbits, this is where this thing should be, and he'll go look at these sky surveys and start stacking them up, and he's refound some of these objects, and then he'll actually report them out. And the other thing that he's done that is really cool is he'll say, hey, this object was discovered, it shows 2019, it says it's 2019, blah blah blah. He'll say, actually, that I believe that asteroid was discovered 30 years ago and it was called this, and he's told me that, and we've looked at some orbits and it's been like, holy cow, like that probably is that same asteroid from 30 years ago that they acquired for 2 weeks and lost.
Awesome.
Yeah, so Sam is an amazing guy on our team, and so we have a little tab on our Discord. So people, man, pick his brain, man. This kid is awesome, and it's amazing the work he did. He walked me through one night taking a sky survey and looking at this. Oh my gosh, Tony, my head was just like gonna explode. I'm just going, putting in Julian dates and all kinds of stuff to get the proper, because a lot of these sky surveys are available. You can find them online. You can download these images online.
Yep.
All day long.
Yep.
And
that's right.
You can do that.
That's the great thing about surveys.
Yeah.
When I was working at the Dark Energy Survey, my job was to work on the data management, and it was we were going to get those data releases out as almost as fast as we could process them, and then we do it again after we got more nights of observing, where we co-added. It's the same thing Guy is doing, and so you just keep adding them up. You keep doing the calibrations. You keep releasing data sets, and because they're a survey, they're available right away. As opposed to, say, if you're trying to use the Hubble Space Telescope to observe, and you're given a few orbits to look at a galaxy, you get that data right away, and it's yours, the principal investigator, but it's embargoed for a year because they have to write their paper. But after that, it's available to the general public. So with sky surveys, none of that's true. You get it as soon as they've calibrated it. Sloan Digital Sky Survey, it's the same thing. LSST is going to be this way when it comes online. And what's interesting to me is I love how you guys are just sort of casually saying, oh yeah, I'm using the Gaia database, or I'm using whatever sky survey it is, but the sheer number of these sky surveys are what I'm finding impressive. How many there are, how much we're looking at the night sky, and it makes me wonder about the whole Starlink thing that Elon Musk is doing. That's going to wreak havoc, I think, on some of this stuff. So all sky, the automated software is going to need to know where every single Starlink satellite is. Otherwise, it's going to come up as an object.
Yeah.
And so you're talking 45,000 satellites when all is said and done there, maybe up to 60,000. And so that's all of the software is going to have to incorporate all that so it doesn't come up with a false object.
Yeah, for sure.
Yeah,
Well, it'll be
so.
interesting to see how it all plays out, man.
It is. That especially, I'm interested to see how it works because, it's going to affect everybody.
Oh, it will. It will.
Yeah.
So, yeah, basically we'll put, one day, and then I'll do, based on uncertainty and decreasing order, that's going to be how the list. So it's uncertainty and decreasing order. So the top list is the most uncertain, and it works its way down. And I'll just produce this list. And then Minor Planet Center, if you're listening, you need a little select all button right here, please. You got to put one in because you have to go through and.
Oh no! You've got to click on all that.
Yeah, oh like, can you guys please put that in there? Like, you have that in your other pages. Can you put that in there? And so what I'll do is when I bring this up, I tuck this away and don't make sure I don't ever close that. Throughout the night, it's like, don't close this page. But we're almost through it, so it's down the bottom here. But yeah, it's like come on, man, just. And you get ephemerals
right?
now.
And this webpage is like 1995 looking.
Yeah, exactly,
too, so.
exactly. Now, here's what's really cool. Look at that. Look what that says. Oh boy, that can't be good. Object is flagged as virtual impactor. What? By JPL. Oh gosh. So we'll get like we'll get 2 or 3 of these a night that come up, and what these are, what I've been told, is these are really dim objects that were discovered for a very short time, and based on the orbit that they saw them, it could potentially, they look at that and go, hey, that could. But here's the thing: these have very few observations on them because they're so dim. There's not even a magnitude reading on here because they're such dim objects. So until we get more, as we get observations, it's very common actually to have, what I'm told is to have these, things be flagged as that, and then they get taken off that list as observations start to come in on the objects.
I wonder what a virtual impactor is as opposed to an impactor. That would be.
Well, yeah, I don't know. I guess maybe that's their way of saying, hey, we have very little, and it's a possibility. But
virtually, it's going to virtually
impact us. But yeah, these actually started popping up a few months ago, these things, and I wasn't sure what they were, but I started kind of researching a little bit. It's like, okay, it's not uncommon for these things to be listed like this, and then as observations come in, they just get better. But because of these sky surveys, some of these objects are just so dim that they're catching them. They're catching this stuff. And and they're looking at. So you start going through, and the big thing we're looking for is things that, what I look for is this useful for orbital improvement. That's the most important thing. So that just means they need more. They're looking for more observations on it to improve the orbit. And we'll start going through, and what I generally do is start scrolling down, and I'm really looking at magnitude, this V magnitude letter down here, to see what what I can grab and what I can't. Some of these, you know what? I don't know why it didn't come up with the magnitude. Let me refresh this page. It didn't work. Let me try this.
Yeah, a lot of them are empty.
They shouldn't be empty. I don't know why they're empty. They weren't empty earlier today. Error. So they shouldn't be empty. I don't know why they are, but basically we're looking at that magnitude rating, and then when I kind of see some that are in the range, I'm looking for this useful for orbital improvement, and then I start looking at the coordinates, and start saying, okay, like, we'll get stuff where I go, oh, that's one, and I look and I go, wait a minute, RA-15, like, oh, that's that's like 4 in the morning, like 3 in the morning right now. I gotta work, man. Well, A-Key hits me up all times, like, hey man, there's a supernova. I go, bro, that's coming up at like 2 a.m. I gotta go to bed, man.
Bro, that's like,
come on, bro.
I was like, no, is that how you gonna do me?
Yeah.
He goes, do you want to do astronomy? Or
I know.
not?
Well, I know. I know.
Come on.
So true. It's so true. I'm so bad. Well, it's actually it's like you gotta have I gotta have a normal job, to pay for all this garbage.
That's right. You got it's something free, man.
So yeah, we just start going through it, and then we kind of formulate. Okay, we can catch a couple of objects tonight, and what I'll do is I'll do a 20-minute, 20-minute run on one, and then I'll wait. The Minor Planet Center wants you to wait about 15 minutes before you take another set of observations. So we'll do a run, we'll wait 15 minutes, we'll do another run, and then we'll move on to the next object, or we'll do a run, move to a next object, and then come back to the other objects. But you need to have about 15 to 30 minutes in between each object. If you don't, the Minor Planet Center will kick back an error to you saying, hey, your observations are too close together and the data is no good, what you're getting. So yeah, that's kind of the workflow on this stuff, on how we're doing it and what we're doing, and as crazy as it is.
Wow.
Yeah.
So what have you discovered? Have you discovered anything that nobody else has seen?
Man, I haven't asteroid yet wise. What's really cool is when you start zooming into some of this stuff, you start seeing some interest. I mean, look at how close these stars are together, and you start seeing some stuff in the images that are a little weird at times, but yeah, no, I have yet to discover anything super out of the ordinary.
So Astrometrica is your main program
That's the main
for
program.
finding these, or at least seeing what you're going to image.
Yeah, taking the measurements for them. Basically, the
Right.
observations is what you do, and the software just plate solves, and it creates the actual file. And I know there's a few other pieces of software out there that you can use, but Astrometrica is kind of the main player in a lot of this.
And your typical exposure times are how long?
15 seconds, 15, 30 max, but generally I don't go beyond that, because the fact is we are imaging stuff that's moving, and we go farther than that, we start getting trails, and we don't want to do that. And that's where it gets tough. It's like, yeah, I probably could stack a whole bunch of images and get 19 magnitude on stuff, but I'm not going to get a good measurement out of it when I start stacking like gobs of images, because what I have found through this is the more images I stack, the more my residuals are not good. and the Minor Planet Center says these residuals are kind of not your timings aren't really great, and it's like,
What do you mean residuals?
well, just the timings of these things, as far as the tracking and the timing that's going on. They have to be super precise, because obviously these objects are moving at a high rate of speed, and we want our tracking and the observation, the focus, everything needs to be spot on. And if it's not, you start getting some weird
I see what you mean.
measurements that just don't work.
What kind of sea do you get north of LA?
Yeah, we're I guess when I look, I'm Bortle 5 is what I'm at, but
Okay.
it's
I don't know how that.
Yeah, it's transparent out here. I mean it's so here's a here's this is the camera right now. This is what is this? This is let me go to a 15-second exposure. Let's look at a 15-second exposure right now. Now again, I'm Hyperstar, so I'm shooting 1.9.
Right.
So I'm really fast, and I'm going to capture a lot of data.
Yeah. So I guess seeing doesn't matter as much at that field of view. So
Let me pull this back a little bit. So there's quite a few stars in that field of view there for being 15 seconds. And I don't know the chat can tell me. I can't remember what is. Third Rock could probably tell me what is 15 seconds on a Hyperstar versus not. How many minutes is that? Equate to. Third Rock knows those figures, I think, pretty well. He'd probably tell me, but
it just affects your star. If you've got like really bad seeing.
Well, it can affect the measurements.
Which are called residuals.
Right? It can affect the residual stuff. So sometimes that happens. The other thing I found is if you take a measurement where sometimes these objects fly in front of a background star, and you don't want to take a measurement when there's a background star that it's gone over the top of, because that can throw off your measurement as well, is what I found. And I've been told, like right now, this object right here, if it was to fly over this background star and I took an image or, took a measurement of it, it wouldn't, the measurement wouldn't be, observational measurement wouldn't be correct based on that. Because of that is what happens. So there's some parameters that we got to kind of follow to get accurate measurements on these things. Third Rock, I was asking, what does 15 seconds on a hyperstar equate to in a normal imaging? If I was to put a camera on the back of, well, on the 14 shooting F11, holy cow, that's like the size of a pinhole. What about you, Tony? Do you do any observations? Do you, what do you? You do a lot of news articles, a lot of stuff I see, but are you setting up a telescope somewhere?
Well, so here's the thing. So I spent most of my, so I started out as an amateur astronomer, then started working in professional astronomy for about 30 years. I had an LX200, a 10-inch for many years, and it just sat in the case. So I finally sold it, and now after I've left the institute and I've done all I wanted to do in the professional realm, and so I was doing deep astronomy outreach and started getting back into amateur astronomy again. OPT's been a big part of that, and so I'm building a system now. But lately what I've been doing is playing with stuff other people are sending me to review. Like I had the Stellina recently. I've got an EV scope over here now that I'm gonna make a video on this week, and so I'm just playing with different telescopes. Dustin, I think maybe, I don't know if I should say this, but so I live on 5 acres, and I want, it's in Central Florida. He wants to put remote observatories in every time zone.
Yeah.
And so I said, well, I'm your Eastern time zone guy. Then you have something here. And so we're working that out now. And if I don't know what it'll be, but it'll be a remote observatory. If that gets built here, then I'm going to be joining a lot of the streamers that are streaming as well. To use that equipment. Don't know what it'll be yet. So that's a really long answer to your question, but I really don't have anything right now that's my own, except for my trusty Astroscan 2001, my 4-inch. I still have that. It's sitting right over there. I also have a PST for looking at the sun.
How's that Stellina, man? What do you think of that thing?
Dude, I can't say enough good things about it. It's not going to replace imaging setups, but man, it looks. My wife saw it, and I put it up on the tape on my desk here, and she goes, "It looks like a router."
Right? No, it does. It does. It does. It's true. It's
a really big router.
It's true.
So I turned it on. I connected my phone to it, and I went outside, and less than 10 minutes, I have this beautiful image of the Crab Nebula sitting on my phone. I'm like, oh, let me see the Ring Nebula. Over there, Ring Nebula comes up. I'm like, wow, this is great. And so I'm looking at that Andromeda Galaxy and then the Orion Nebula and all these different things. And I got to thinking to myself, all those years I spent with hypersensitized 2415 film, trying to polar align my scope, spending hours finally getting the focus right, taking images. I don't know if anything's going to come out of it. And when I finally develop the film, most of the time it's not. And, it's like, this is a different world, right? And of course, I'd work with professional equipment. But the Stellina is a game changer for people who are just getting in the hobby. It's expensive. Yeah. But if you think about all the stuff you're getting with it, you'd spend all that money anyway. Things like dew shields and go-to capability and, CCD cameras and all of that, anti-reflection coatings, all of that stuff. It adds up. Oh, so, I think it's great. I don't think it's not a imager's dream, but it is someone who wants to get into to star parties or get into just visual observing. I think it's going to overcome the limitations that we have with our night sky, because I'm a guy that likes to look through an eyepiece.
Yeah.
Me and David Nagler are like this. I love him because he's on the same wavelength as I am. He goes, I love telescopes, but what I like is the view when I look through an eyepiece.
Yeah. for sure.
You know, he loves imaging and all of that stuff. But the thing is, that's with light pollution, that's going away.
It's a lost art.
You know, you need a 14-inch C14 like you've got, and a big, you know, another $1,500 Nagler to put on there, and you might see some detail in the Orion Nebula.
Well, and
so
it's right. Daniel Moundsey and I were talking about it all the time. It's that because he's just one of the best visual observers I've ever met. But it's like that whole art has just gone away.
Well, it's not, and it's being imposed on us by our night skies and light pollution.
That's right.
So I actually believe visual observing, and people get pissed at me when I say this, I think it's dying. I think visual observing is a hobby that is going away. So what do you replace it with? Yeah. Well, here you've got the Stellina, who will show you the Orion Nebula in a way you've never seen through an eyepiece right away. It's not going to be some beautiful, super, great image, but you're going to be able to see it, see detail, and you could share it with everybody that's with you on their own phones right now. I get it. The phone situation, the small screen, is not the same as looking through a telescope. I agree completely. But if you want to see these objects as they are tonight, when you look up in the sky and the telescope is pointing at the Crab Nebula and you're seeing it and you're looking and you're doing, and it's like, yeah, okay, that's a connection. It's not the same kind of connection as you get with an eyepiece, but it is still a direct connection between the photons there and what you're looking at on it. So for visual observing, I think it's the future. And the EV scope uses light amplification to overcome light pollution, right? And it does some processing on the fly as you look through an eyepiece. So this one, it's got some bugs, so they're not done with it, but it's also on the right track. At least there, you're looking through an eyepiece.
Well, so, it does break my heart that I will say that I think a lot of people, get in today and they may not take the route of ever putting an eyepiece on a telescope. They just go right for a camera, which I understand. I totally get. But I'll tell you, I'm going to tell you right now, some of the best times that my son and I have had together is we literally set up a telescope outside. We order a pizza, and I open the. I love the Burnham Celestial Handbook are some of my favorite books, and we'll open those things up, and we'll just start kind of looking at stuff, and we'll just talk about what we see in the eyepiece, and we just are literally just visually looking and talking about, and we'll read through the book, and it says, hey, you should see this star and this part of the nebula or whatever, and it's like, do we see? Oh yeah, and we just have great discussions, and some of the best times we've had have been doing that, without even putting the camera on. It's incredible,
Me too. I love that stuff, and I will miss it.
Yeah.
When it goes. I mean, freezing cold nights behind an eyepiece, direct connection. Those photons are hitting you, just like just like what Starchface is saying here. It hits you, and that's a direct connection. But this kind of thing is next. It's the next best thing, I guess. Yeah. At least there, you can set it up and you can share it with other people. 20 people or so can get on and get that interaction too. And it was exciting. I loved watching these images build up on my phone and watch it get better. So,
I was impressed. I saw the video where they went to Vegas and shot from downtown Vegas.
Yeah, Galactic Hunters did that.
Holy cow, man. Mm-hmm. I was impressed. Yeah. It actually showed an image, which I would never think would happen, So,
other people's telescopes. I never heard.
Oh, OPT.
Yeah.
Come on, guys. You got any questions? We got Tony Darnell on the stream here, man, and I know it's getting late for him, so he's
I'm gonna have to head out pretty quick. Well, Third Rock wants to see the raw files. Oh, you mean on the Stellina? I do.
Yeah.
What do you mean raw files?
Talking about the Stellina?
Yeah. Okay. Yeah, I didn't get a chance to download those. If you connect a thumb drive to it, it'll save the raw FITS data, along with the calibration images that it took and whatever else it used. So I didn't get a chance. I didn't have it long enough to see that. But I mean, the JPEGs you get JPEGs on your phone, and of course that's crap because you get it's compressed and noisy, and I did notice that the dark subtraction was was sometimes a little. I mean, the background noise was. If I waited to, it's like they took one when the camera was at a certain temperature, and then it got to a different temperature. You could tell the difference in the dark subtraction and the whatever they were doing, flat fielding, if they were doing it.
Yeah.
Because it's, I mean, I didn't get to find out what their calibration steps were in there. But you're right, the fit data would have been nice to. I should have looked. Just didn't have time.
Sure.
So.
Right on. Well, Tony,
Yeah.
I know it's getting late for you, man, and I can't thank you enough for sticking around with us here.
Well, thanks for letting me.
Are you kidding me?
Join in, and
I hope this is just the start. You know what I mean? With us.
Hey, I'm here. So if you want to stream, we should try this. If you want, I could try doing something where I stream to my channel on YouTube if you're game.
Oh, are you kidding me? Absolutely.
Maybe gain some exposure to people who don't know what you're doing.
That'd be incredible. That'd be incredible for my son.
But we'd have to figure out how I'm going to grab your stream and do,
Yeah, we'll work through it. But
or
there's
maybe you
always
can just
a
stream
way.
to my channel, actually.
Yeah.
Yeah, of course. I can just give you a stream key and you can just stream to
right
that.
channel. That's true.
Yeah.
Okay.
Yeah. Okay. All right. Well, let's talk
thanks.
about that. That'll be fun.
Okay.
Uncle Bill, it's good to see you again. And Third Rock and Aki and all you guys. That's right. That's you. Third Rock, all you guys. Thanks for being here and chatting with me. And go find some more. Go get some more orbital elements.
We will, man, for sure. All right, buddy. Well,
Starchface, it is better, but I'm on YouTube more than I am on Twitch.
Well, yeah.
The way I
YouTube
see it,
pays the
YouTube is
bills,
better
you
for
know what I
some.
mean? Come
Twitch
on,
is better
baby.
for others.
Say that again, Brandon.
I
What'd you
said
say?
the way I see it is YouTube is better for some people who like the shorter videos, and Twitch is better for the longer.
True.
Videos.
Attention span is not high.
It's true.
Definitely vouch for that.
For sure. Well,
right.
we will try to we try to do some of that stuff, but yeah, it's a challenge to be on both platforms. But we'll work through it.
Yeah.
But, man, can't thank you enough, and we look forward to doing some more here. So.
Well, thanks for having me, guys,
Yeah.
and you have a good night, and see you guys later. Talk to you soon.
Okay.
Bye-bye.
Thanks, Tony. Take care.
Bye.
Uh-huh.
How about that, guys? Tony Darnell on stream. Woo! Checking us out. We're grateful. Thanks, Aki, for getting him on the team. It's awesome. We're glad to be have him aboard. He is in the Discord as well, on our Discord there. So for Asteroid Hunter. So if you haven't joined the Discord, please do, man, and you can talk to him there and ask questions. And like I said, we put the science tab in there tonight, so you can have conversations with Sam as well, and talk some asteroid talk in there. And please, you like what you guys see, appreciate the cheers, man. Thank you. Thanks for the follows, guys, and be sure to subscribe to the channel if you haven't already, and get some merchandise. We gotta send Tony a hat, man. I gotta send Tony a hat. We got a merchandise store. You can get a shirt. We're rocking the shirts tonight, guys. I hope Aki's got his shirt on, man. Come on. So we got some hats. You can buy this banner that's behind us actually as well. Also, guys, telescopes.net, they are putting together an imaging package for our viewers solely. Let me do this here real quick. Let me give you this information on this. So they're putting together an astro imaging package. I believe it's going to be a red cat and a few other items, actual mount and stuff. They were trying to get that to me today, but I just wanted to kind of give you guys a heads up that they are going to do it. It's going to be special pricing only for the people that watch the channel, and so we want to offer that to you guys, just in case you're out there maybe looking for some actual equipment. You can put Asteroid Hunter in the promo code at checkout. If you guys go to telescopes.net, order anything, put Asteroid Hunter in the promo code there at checkout, and you're going to get
those deals.
Get an actual discount on your order there. So, well, there it is, guys. There's a stream. It's going to be sweet and short tonight, but we can't thank you enough for sticking around, man, hanging out with us. What an awesome night, man. Great time. And this is just the start. You just heard Tony. We're going to be doing stuff with Tony, hanging out with Tony, and We got a few other guys we're working with, and we're looking forward to having more guests. I got a friend down in Australia. If you're watching, you know your name. That I'm trying to get on stream. He's super busy, but he is our buddy down there in Australia, and we're hoping to get him on stream soon as well. That's right, Dylan. Stop hiding from me, buddy. I keep reaching out to him. He wants to get on stream. He's busy, but we're hoping one day to get Mr. O'Donnell on stream here soon. So that's right, Crocodile Hunter. So all right, guys, man. Well, appreciate it, and hey, please also check out our other stream we got running 24/7. And Brandon put a link to that there.
Give me a second here.
Our Earth stream, man. We need people to watch that thing. We need to. It's so funny. We just need to average like 3 viewers. We're like 2.8 or something. We need some more viewers on that thing. So we're trying to keep the camera going. The space station keeps dumping the live view camera, man. So can somebody call them up there and tell them to get that together, man? Does somebody know somebody up there?
That's like buggy.
The thing's buggy, man. Who knows somebody on the space station they could call? Come on, Aki, don't you know somebody, man? Don't you got a number you can call up there for that? We need that. Want to be good. So yeah, if you guys could, follow that stream. That's we leave that running 24/7. So it's real nice to put up on a big screen or something. So, but yeah, we're hoping to get a few more targets over the next few weeks as we go along. I'm kind of messing around a little bit with my measurements on some of the deeper images. We did some images on asteroid a few days ago that was at like almost 18 magnitude. I've kind of sent those into a few guys just to give me their thoughts on them, just to see, because I don't want to send anything that's not great. So we're still just trying to iron out this 14, but we definitely have our plate solves are rocking with the new. We took some good flats the other day, so those are rocking really well. And we're getting some good plate solves with that. So I know the measurements are going to be spot on as we move forward on these objects here. So, but yeah, I'm just trying to think if there's anything else. So yeah, we're gonna just keep going as we as the weeks go by here, and keep taking some measurements. So. Fooney, when is Greg back? He's going to be streaming again soon, isn't he? Greg will be back on stream showing that optoscope, man. That'll be awesome. I know you can control that thing remotely, which is very cool. So, oh. All right, guys, is there anybody on right now, Brandon?
We could raid. You want to keep it in the science and tech category? Right?
Yeah.
I don't see anybody on. Yeah, I don't see anyone.
Where do you guys want to go, man? I can push you somewhere. Where can we push you?
You want to push him to... You could push him to Bobby's stream. He's live right now. You want to help him out?
No, he's playing, right?
Funny, though. He's playing, though.
We got a big night. We got a big
yeah.
Fortnite event, guys. It's going on next season tonight, so my son and I are actually going to be up all night. Yeah, I'm going to let the telescope do some running on some things, but we'll be up. The Corona cam. That's right.
You just push to the other channel.
To who?
To our other channel.
Okay, we'll do that. I'll throw you guys over to the Earth channel. There's nobody on tonight, so. Yeah. But man, appreciate you guys watching. We're just so grateful to have Tony, and what an awesome night. So, we'll be back again next couple days. Maybe possibly Friday, if not Saturday. We'll be back here again, and we'll get some more targets, and we'll do what we do. We'll just keep doing what we do, guys. But thanks again for the follow, the cheers. Thanks, Aki, for the cheers, the bits. Again, if you guys can, subscribe to the channel. And keep following us as we hunt these asteroids, man. So, all right, guys. You guys have a good night, and we will talk to you again soon. Take care.
Bye, guys.